You're weak and you're gullible, and I don't care. And I don't care. You're a walking disaster, and I don't care. And I don't care. You're wasting our time, and I don't care. And I don't care.
plus, because I know I want to do something 3 times. But what do I want to do 3 times? This loop kind of represents in my mind's eye row, row, row. So in fact, I could be more pedantic. If I want my I to mean something beyond int, I could say row equals 0, row less than 3, row plus plus, just to help me think about it. And then what do I want to do on each row? What do I want to print? Like column, column, column. So brick, brick, brick. So how do I print 3 bricks or any number of bricks? Well, I could kind of cheat and just do printf hash, 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 backslash n. But again, I can't generalize. I can't take an input from the user and print 4 or 5 or 6 bricks. So that's going to get me into trouble eventually. So maybe I could use a loop. So I could do like for int I equals 0, I less than 3, I plus plus inside of my loop. And then in here, I could print out 1 hash. And that's kind of on the right direction, the right path, because now I'm just using the simple building block or brick, but reusing it again and again. And it's totally fine to have nested these columns in this way. I used I out of habit, but what would a better name be? Well, maybe column, or maybe just COL, call for short, so that my code is sort of saying what it does for me. And I don't have to use row or column explicitly. I don't need to print them, but I am using them as counters, one after the other. So let me go ahead and run make Mario, /Mario. And I'm feeling good about this, but damn it, there's 9 bricks, but they're not really laid out right. Why? What's the fix? Yeah. Yeah, I never went to a new line. And let me do what I think you're not going to suggest I do. Let me just go to the obvious place. All right, well, let's put one right after the brick. But of course, if I do make Mario, /Mario, I'm making the same mistake as before. I'm printing out too many new lines. So in between, what lines do I actually want to print a new line? Between, yeah. Yeah, so 10 and 11. So outside of the inner loop, but inside of the outer loop. So it happens again and again. So let's just print out as before a single \n semicolon. Now let's do make Mario, /Mario, enter. Now it's generalized as I see fit. And if I really wanted to dwell on this, I could go in and I could prompt the user with getInt or with getPositiveInt, figure out what row and or column should be. We can make any size brick that we want. But now we have sort of a nice starting point. But there's another way to think about this, because I dare say, especially for like your first CS50 problem set, if you're trying to print bricks in the world of Mario in this way, it's probably not going to be obvious to come up with loops like this and just magically get it working after like 45 seconds in total. Like it'll be a struggle at first. But there are some patterns to follow. So one, it's pretty conventional, nonetheless, to use just I and then J and then K and then L. And if you've got nested, 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 nested for loops, at some point nesting, you're probably writing bad code. It's not well designed. But 1 or 2 or maybe 3 nestings could be an OK thing. But you cannot use and reuse I again and again. Why? Because if you're counting I here, but then you're changing I 3 nestings, could be an OK thing. But you cannot use and reuse I again and again. Why? Because if you're counting I here, but then you're changing I here to do your columns left to right, you're going to get all of your math out of sync. So you need 2 separate variables. I and J are conventional, or row and column would work too. But if we go back to this idea of rows and columns, well, let me actually factor something out here. And this might help you instead. Suppose that you set out on this problem. You know you want to do something like 3 times, but you don't quite understand how to print those rows. Well, take a baby step, a bite out of the problem, and maybe do this. Create a function with no output, just a side effect, whose purpose in life is to print a row. And how many rows? Well, maybe n for some number of rows, for some number of bricks, rather. How do you print a row of bricks? Well, let me just think about this in isolation. How do I print a single row of bricks? That's easy. For int I equals 0, I is less than n, if I'm generalizing, I plus plus, and then, whoops, I plus plus, and then inside of my curly braces, go ahead and just print out a single hash. And at the end, as you suggested, print out a single new line. In other words, abstract away the idea of printing a single row. And in fact, at this point in the story, especially if you're struggling to get started, you don't even need to start with main. Like, take a bite out of the problem that makes sense to you, that's smaller than the whole problem, printing a single row. Because then you can come in and iterate. Then you can go in and say, OK, now let's write my actual main function. So int main void as always. And now what do I want to do? I want to print out a whole bunch of rows. How do I print out a whole bunch of rows? Oh my god, it's like the same idea. For int I equals 0, I is less than, let's call it 3 for now, but we can generalize that, I plus plus. And what do I want to do on each iteration of this loop? My gosh, just print row with 3 bricks. And then we're sort of done, right? Again, out of sight, out of mind. This function can go away and never be seen before, because once print row exists, that's what it in fact does for me. Now, this isn't 100% correct. I still need my prototype, because if I've made my own function, I need to tell C in advance that it shall exist. So I need to copy and paste that one line of code. If I were really being pedantic, this is bad design. In general, when you have the same number in multiple places in a programmer would call this a magic number. Like, how is that working? Like, you're just an honor system that you're using the same number again and again. So a better solution here, even if you're not going to take user input, would be to do this. Int n equals 3, and then use n here, and then use n here. Or you could call it anything you want, but now you've specified 3 in one and only one place. And we can go one step further. It turns out in C and in other languages, you can protect yourself against yourself. If you know that a variable should never change its value, it should always stay 3 in this case, you can use what's called a constant, where you can specifically say, I don't want just n to be an int. I want it to be a const int. Const for short, for constant. And this means even if I try to change n in my code, the compiler will not let me. So I can protect myself from myself, or in the real world, you can use a variable that none of your colleagues can foolishly change on you without you realizing that it has happened. So a lot of programming, honestly, is just, not trusting yourself the next morning when you've forgotten what code you wrote, let alone the next month, the next year when you're writing code in the real world. So constants just give us a feature to defend against ourselves. There's another feature that's useful too, especially when you wake up the next day and you're like, oh my god, like how does this code work? What does it do? Well, there's comments in code. And some of you might have used this in Scratch. You could add little yellow sticky notes in Scratch for comments. In code, you can do something like this. You can, if you want to put an English reminder to yourself, or if you speak some other human language, a comment in Spanish or any other human language, you can write it with a // at the start of the line, and then you can say something like print n rows. And then this tells you in a comment what those subsequent lines of code are doing. It's sort of a note to self. It has no functionality for the computer's sake. It just is a note to on any of these Mario problems that we have solved. No? All right, so one final set of examples that push the limit of like what computers can actually do. Thus far, we've solved like every problem I proposed. That's because I've kind of been skirting some of the underlying challenges. So it turns out that we have not only functions that give us side effects, like visually on the screen, we again have functions that have return values. So let's focus on those and where things can go wrong, and let's use a bunch of other operators as well. Suffice it to say, computers got their start by being really good calculators, so computers support addition, subtraction, multiplication, division, remainder operators, represented by the percent sign here, which says take the remainder of something over something else, and there's even more operators than this. So let's go ahead and implement our own calculator of sorts that actually has some bugs along the way. Let me go back over to VS Code here. I'll close mario.c, open my terminal, and code up one final file called calculator.c. And in this calculator file, let's go ahead and do something super simple initially. Let's go ahead and include cs50.h. Let's include standard.io.h. Let's do int main void as always, all boilerplate thus far. And now let's do something more interesting. Int x equals getInt, and we'll prompt the user for an x value. Int y, prompt the user for a y value, as we've done previously for comparing numbers. And let's just do something super simple. Let's give myself another variable, int z equals x calculator file, let's go ahead and do something super simple initially. Let's go ahead and include cs50.h. Let's include standard.io.h. Let's do int main void as always, all boilerplate thus far. And now let's do something more interesting. Int x equals getInt, and we'll prompt the user for an x value. Int y, prompt the user for a y value, as we've done previously for comparing numbers. And let's just do something super simple. Let's give myself another variable, int z equals x plus y. And then let's print out the